Хорошо, давайте начнем сегодняшнюю лекцию. Түсіндің ба? Нешінші жылдары қандай жетістіктер?
Anymore, because it doesn't meet the new definition. It is a step in the step in the process. It is a step in the process where a control measure is applied to a significant food safety hazard, and it can reduce that hazard to an acceptable level. However, for a sieve, we don't use defined critical limits in measurement. We use the judgment if the sieve is intact or not. So what we'll do is, when monitoring a sieve, we'll do a visual inspection and look at it and say, okay, well, the sieve seems to be fine. It's perfect. I've looked at it and I just write in my little notebook, the CCP is under control. And we do this once a shift, once an hour, once a day, whatever frequency we've decided to do it. Well, now we can't call that a CCP anymore. Only those steps in the process we're monitoring yields a number, a measurement, temperature, time, chlorine solution, Gauss, pH, a number that we're going to be derived from the measurement, and then we can call it a CCP. So anything that's being observed is not a CCP anymore. Big change. And this is because of this big change. An OPRP in 2005 was a PRP. And as soon as we understand it's a PRP, then anything that's not a PRP couldn't have been an OPRP. So anybody from 2015, 2018, who called anything that's not a PRP an OPRP was making a mistake, because it's not a PRP. So it used to be that an OPRP is a PRP that was identified by the hazard analysis as essential in order to control the likelihood of introducing food safety hazards, blah, blah, blah. And the way we understood this, most of us, was that we now have a term that we can use when we have a critical PRP, because the CCPs are critical steps in the process, but everything around the process, the PRPs, the prerequisite programs. Now, the definition for a PRP has not changed. It is still the same. A PRP is a prerequisite program. It includes hand washing, sanitizing, SSOPs, SPSs, pest control, glass control, metal control, purchasing practices, cleaning, sewage, keeping the building, hygiene. Those are all of our prerequisite programs, our PRPs. And if any one of those elements in the past was identified to be crucial, for instance, monitoring glass and brittle plastic, or sanitizing hands, or preventive maintenance of equipment, if any one of those had been identified in 2005 as being critical, then we could call it an OPRP instead of just a regular PRP. Well, what the writers in the standards are now saying is something a little bit different. And try not to get confused. At the bottom line, it's not that confusing. 2018, they have totally removed the previous definition of an OPRP and written a whole new one. Okay, and the new one says that an operational PRP, an OPRP, is a control measure. And remember what a control measure is. A control measure is any action that we can use to reduce or prevent a significant food safety hazard. So control measure or combination control measure applied to prevent or reduce a significant food safety hazard to an acceptable level. So up until now, this is an exact same definition as a CCP, exactly the same, without the step in the process. And the addition explains what they mean and where action criterion and measurement or observation enable effective control of the process or product. So no more critical limit and no measure, which is mandatory for CCP. to make sense of this, of everything I've said till now, the bottom line is as follows. If any control measure now is anything that we do to prevent or eliminate or reduce a significant food safety hazard anywhere, anyhow. They are classified into two names. There's CCPs or OPRPs, all of them. If you are a step in the process and you are being monitored regularly and you are yielding a number, a measurement to make the decision if the product is under control or not, you are a CCP. Any other control measure that does not meet that description is an OPRP. Okay, I'm going to say that again, just to make sure we're clear. If there is a control measure that is a step in the process, and it's essential to control measure because it's now essential to reduce or to prevent a significant food safety hazard, and monitoring yields a number, a measurement, then you are a CCP. Anything else is an OPRP. So we can now find two different types of OPRPs. The first type of OPRP will be those OPRPs that are steps in the process alongside their CCP friends, but they're not measurable. They are observable. So they're now OPRPs. So along the process, as we go through the process, we will have steps in the process that are CCPs, and steps in the process that are OPRPs, and steps in the process that are nothing. In addition, if you are a PRP, in other words, you are being applied not as part of the process, but around the process, like hand sanitizing, like preventive maintenance, like pest control, glass control, and you are crucial, you are essential to reduce or prevent a significant food safety hazard, you're also an OPRP. And that is the old version OPRP. So that hasn't changed. That was always an OPRP. But now it's also an OPRP in the process. So Mel, you're right. It is not necessary to the last point in the process where you can control the hazard. Okay? So this is not true anymore. It's not the last one. I'm answering Mel Morris, who made a comment, and the answer is no. It's not necessary to be the last point. What is necessary is to be the most effective. So if I do have a few control measures along the way, and I want to choose which one's going to be CCP, then I will choose the one that is the most effective, not necessarily the last one. And that makes a lot of sense. That makes a lot of sense. Because if the hazard coming in is a hazard that's being introduced from raw materials, I wouldn't like to keep it in my plant all the way to the end. I'd like to eliminate it as soon as possible. So sometimes I will use the last point, sometimes I won't. And Eric is saying, so what do we call metal detectors as a CCP? Good question, Eric. The jury is still out. It's arguably a CCP because using the dummy probes, using dummy probes, metal, ferrous, non-ferrous, and stainless steel probes to monitor your metal detector will derive a decision that is a measurement. So it is under 2.5 millimeters or under 4.5 millimeters. So you can still call it a CCP. Some people will argue, no, that's an observation, so it should be an OPRP. Well, you know what? It doesn't make a difference. You can call it either a CCP or an OPRP. You're still going to be doing the exact same things to it. So as far as that, so the jury is still out. So no, John, no. John's asking if every PRP is an OPRP. No. A lot of PRPs are there because they're important, just like a lot of control measures that in the past weren't critical and still aren't critical. We have them because they are part of the whole idea of making food safer. So everybody washes their hands all the time. In most occasions, that's not critical, hand washing. People who wash hands in warehouses and in raw material areas, it's not crucial. Only those people who are touching ready-to-eat product with their hands, for them, hand washing will be an OPRP. For others, it'll be PRP. So not all pest control is an OPRP. A lot of PRPs, most PRPs are not OPRP. Okay, so let's now go into the standard. Oh, sorry, I owe you an explanation for this. This new term, action criterion, has been introduced in 2018. It replaces the critical limit for OPRPs. Because OPRPs don't necessarily have a real measurement, don't necessarily have a measurement, then they get an action criterion. It's a new term. It's the same thing as a critical limit. It means a measurable or observable specification for the monitoring of an OPRP. So still, even if you have an OPRP that's being monitored with a measure, for instance, you're using an ATP swab to verify cleanliness. Well, that's part of your PRP. That's not a step in the process. So it has to be an OPRP, the cleaning, but you are measuring when you do the monitoring. So it could be measurable or observable. For instance, our glass covers, our light cases are intact. That's observable. Or our sieve is intact. That's observable. So that's an action criterion. Okay. Now, this is just a note that I quote from the standard. The standard has notes. It says an action criterion is established to determine whether an OPRP remains in control. And it distinguishes what is between what's acceptable and unacceptable. And if you read the light font, it explains what acceptable and unacceptable is. Acceptable is criterion met or achieved. That means it's operating. Unacceptable, not met or achieved, is not operating as intended. So it's the same thing as a critical limit, but it's not a measurement necessarily. It could be an observation, or it could be a measurement offline. So yeah. So Taro Ora is asking storage temperature finished product to CCP OPRP. Storage temperature would be an OPRP because it's not a step in the process. If somebody calls it a CCP, they're a champion. It makes no difference. And the good news is, as long as we identify a control measure, it doesn't matter what name we give it. Well, it hardly matters what name we give it. We're going to go further deep into the standard and see that there are places where there are clear differences between CCPs and OPRPs. I don't like any of them, but they're in the standard. So let's go on and see what that means. So just a comparison graphic, CCP, OPRP. Let me just change my transition. Can I do that? Hang in there for a second. I don't like the way it's trans. Let's try this. Better. That's what I wanted. Okay, that's a good, better effect. Okay, you still with me? All right. So so just compare CCPs with OPRPs. Okay. So a CCP is a step in the process. An OPRP is a control measure or combination of control measures. It doesn't say that it's not a step in the process. It could be, but it doesn't have to be. A CCP must be. Second difference, CCPs are defined when we monitor them according to critical limits, OPRPs according to action criteria. CCPs, we use measurement only. OPRP can either be measurement or observation. So anything that's observation is not a CCP anymore. And finally, with CCP, it says that the CCP will enable correction. And what an OPRP, it says it enable control of the product or process. Now, this is a real important difference between them. One of the ones I don't like, but we have to learn to live with. Because we're not measuring something, there may be cases where we're talking about control of the product or process. And the way we understand that is when we have a violation of a CCP, then we immediately stop, and we can, and our reaction is immediate. We know that we had a violation within hours, and it can be corrected. Sometimes an OPRP observation will happen at the end of the day, and it will be, and it won't be as timely as a CCP. So then we don't say we can enable correction, we can just control the product or process. What this means is, we go into detail, truthfully, it's the same thing. But some people argue that if you're doing it at the end of the day, or maybe the next day, then it's not a correction. Still, the principle that it cannot leave the plant is valid for both of them. If a product has been produced where the action criteria have not been met, or the critical limits have not been met, it's the same thing. It can't leave the plant unless, and we'll get to the unless in a second. And and I do agree with Naronkai, who's saying, I hope you're pronouncing your name properly. OPRP looks like the preventive control in FSMA. Yes, yes, yes. It's worth making a note that both FSMA and ISO 20000 2018 do not make mention of the term HACCP anymore. And it's a sad moment in history where HACCP has officially been retired. The term HACCP. It's mentioned in, if you go through 20000 and do a word check to see how many times HACCP appears, it appears once in parentheses in a note. It has no meaning in the standard. Same thing with the FSMA. FSMA has replaced HACCP with HARPC, which is not focusing on critical control points, because HACCP is hazard analysis and critical control points. So the whole point of HACCP is the CCPs. Well, both 22000 and FSMA say no, hazard analysis and risk preventive controls. So not just critical control points. And this is a strong message to the industry in general, a very strong message, saying that HACCP is not just about cooking your chicken. It's not just about pasteurizing your milk. It's not just about putting on a metal detector. It's much, much wider than that. It's not HACCP anymore. It's a food safety management system. Okay, so let's move along. Item 8.2, the PRPs. Big change here. When selecting and or establishing PRPs, the organization shall ensure that applicable statutory blah, blah, blah. Same thing. This has not changed. This has changed. This is the mention of this. It's not mandatory, but it should consider. I want to remind you that ISO Technical Specification 20002 series is a way to spell out the PRPs for those organizations that have not developed their own. And it's very similar to the BRC requirements, the IFS requirements, SQF requirements, just a list of requirements included in 2002. The great thing I love about 2002 is that it's delivered to us in 5 different formats according to where we are in the food chain. So food manufacturing, catering, farming, food packaging, and feed, 1, 2, 3, 4, and 6. If anybody's wondering where 5 is, 5 has been suspended currently. It is intended for food transport and storage, and maybe it will make a comeback someday, but right now it's not published. And these are all published. These are all available in different languages. So and using the word should, I want to remind you, in high-level structure standards mean you don't have to. Otherwise, it would say shall. So in English, we say should is a recommendation, shall is a requirement. That's the way the English language works in ISO. Okay, 8.5 hazard control. This is the 8.5 is what used to be HACCP. The 12-step program, 5 preliminary steps, 7 principles. They're all hidden in 8.5. 8.5.1 preliminary steps. Maintain document information, raw materials, ingredients. Nothing new here. This is the same wording. The news is, wait, I made a mistake. Oh, sorry, there is big news here. Am I sorry? My mistake. Back up. I want to emphasize something really important here. It says that organizations shall maintain documented information concerning all raw materials, ingredients, and product contact materials to the extent needed to conduct the hazard analysis. This has always been written, no change, but we have a few things that are really interesting, and we'll see them here. So, I don't know why I'm missing a slide. I'm missing a slide. Let me just peek for a second. Hang in there. Okay, I don't know. I'm just gonna say, I'll talk about it anyway without the slide. Okay, so sorry about that. The organization will maintain documented information. What I want to make a point of here is that when we talk about the information needed to do risk assessment, when we talk about raw materials, the new standard mentions two things that had not been mentioned before. One of them is the country of origin of the raw material used. So it is part of the risk assessment, and that may have an effect on decisions made by the team. And also the technological origin of the raw material. Is this a material that is it coming from animals, from plants? So we're talking about things like ingredients like lecithin or gelatin could have different, they could be coming from different sources that should be identified as well. That's what I wanted to say here. Okay. Okay, hazard identification, that's the first part of HACCP, identifying hazards. Organization shall identify and document all food safety hazards that are reasonably expected to occur in relation to blah, blah, blah. This is not new. This is new. Hazards should be considered in sufficient detail to enable hazard assessment and the selection of appropriate control measures. This is one of the things that I applaud with the new standard, because it was, me as an auditor for years, I've been requiring this. And people have been saying, well, you know, you may think that it's important, but it's not written anywhere. Well, now it is. Hazards should be considered in sufficient detail in order to enable hazard assessment and the selection of appropriate control measures. I'm going to give you an example. So here we have an example. People here, they're putting together sandwiches. Hazard identification. So in the 2005 version, you could just write in your Excel sheet, in the identification of hazards, just write pathogens. That's the hazard. Well, and then I would say, hey, you can't write pathogens. You can't do that. Because what pathogen are we talking about? And they'd say, well, that's how we do HACCP. Sorry. Well, now it says you can't do that because this says in the standard. That's not sufficient detail in enable hazard assessment. You can't choose appropriate control measures because there are all kinds of pathogens. So now I'd expect to see something beautiful like this. Introduction of pathogenic organisms resulting from human-hand contact, and then continue to write fecal viruses, fecal bacteria, fecal worms, protozoic fecal parasites, okay? Staph aureus, now you're talking, now you're doing a risk assessment. Without specific reference to every single pathogen that can be transmitted from human hand to food, and talking about it and understanding its likelihood and its severity and its control measures, you're not doing a risk assessment. So, so it's important for me to, and I'm so happy the standard now gives us auditors a tool to say, hey, I'm not accepting this. It's unacceptable. So no more pathogens, no more foreign bodies, no more bacteria, chemicals, blah, blah. No, specific enough to be able to do a risk assessment. It's going to take you more time, more effort, but it's going to be more professional. Risk. This is the second part. Once we do identification, then we do risk assessment. The organization shall evaluate each food safety hazard. Now remember, pay attention, everything we identified until this point is still a food safety hazard. It's not significant yet. Now we want to see which ones are significant, which ones are not. In 2005, the possible severity of adverse health effects and likelihood of their occurrence is what we use to do the risk assessment. So you take each food safety hazard that was identified and evaluate the possible severity of adverse health effects and the likelihood of their occurrence. And then you put that together and get your risk. And in 2018, they made a change that is really, I'm really happy they made, that clarifies one of the biggest pitfalls in the HACCP system from forever. And that is the assessment of severity. In many opportunities, I've seen cases where organizations assess the severity based on the actual severity in the presence of the control measure. That's a big, big mistake, but it happened often. In 2018, it says we will base our risk on two things. A, the likelihood of its occurrence at the end product prior to application of control measures. So if I'm trying to assess what is the likelihood of somebody getting shigellosis from hand contact with a sandwich, in 2005, people could say, oh, severity is very low. It's low. It never happened to us. It never would happen to us. People wash their hands. People, blah, 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 blah. Well, the question is not that. Prior to application of control measures, the people hadn't been washing their hands. People hadn't been taking care of their hygiene. Then what would be the likelihood? Oh, that's a different story. Likelihood now higher. When we stick to this, we'll be receiving more significant food safety hazards, specifically much more OPRPs. We'll be seeing more of them, because if you ask yourself, well, what would be the occurrence of that specific hazard if I hadn't been doing preventive maintenance? Oh, that's a different question. If I hadn't been doing glass control, okay, now you're talking. So now we'll find out that glass control, preventive maintenance, hand sanitizing, things that previously had an opportunity to go under the radar because this misunderstanding of the likelihood is now very, very clear. And finally, we did identification, we did assessment, and now the hazard control, the HACCP plan itself. So a new term, HACCP control plan. This is a new term. Okay, previously in 2005, item 7.5 was OPRPs, item 7.6 was CCPs, that was 2005, and now everything's been put together into one 8.5.4 called the Hazard Control Plan, the HACCP/OPRP plan. And that's why I said it really doesn't make a difference if you call it a CCP or an OPRP. Doesn't make a difference. You're going to be seeing the same things. Okay. Critical limits and action criteria. CCP, conformance with critical limits shall ensure that the acceptable level is not exceeded. That's not new. That's always been that idea. OPRP, and this is one distinction, 8.5.4.2, that I dislike, strongly dislike, and I encourage everybody listening, all 371 of you, to find a way to disregard this. Because what it says is that an OPRP, when you talk about the critical action criteria, conformance with action criteria shall contribute to the assurance that the acceptable level is not exceeded. Not ensure, but contribute to the assurance. Now that is wording that is a little slippery, and I don't like it. I don't want anything to contribute to the insurance. I want it to ensure. There should not be a difference, in my opinion. So I'm willing to argue that the monitoring systems, let's compare CCP and OPRP. The monitoring system and frequency shall be capable of timely detection of any failure to remain within critical limits, to allow timely isolation and evaluation of the product. That's CCP. That makes sense. That's perfectly true. That hasn't changed. So the CCP is going to be monitored in a way that if we do detect the deviation, we can isolate and evaluate the product and it won't escape from the plant. The OPRP now says, and this is new, that the monitoring should be proportionate to the likelihood of failure and the severity of consequence. So it's a little more loose. Again, because there may be OPRPs that are not part of the process, that are more difficult to monitor regularly. They may be monitored once a day. Then we're saying that we're going to monitor proportional likelihood of failure and severity of consequences. Give you an example. Let's say I have my glass control. So okay, you know that we will watch our lamps every day. They're always intact. Don't worry about it. Nothing's going. If it breaks, then we'll know what to do. We'll find out. So we'll do it at the end of the day. At the end of the day, during cleanup, we have a checklist. We'll look and see all our lamps are intact. If anyone is broken, we'll deal with it because they're not directly above the product, blah, 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 whatever. And that's why we're doing it once a day. That's why we chose our frequency. I would prefer, and if it were my plant, I would treat an OPRP just like a CCP when I talk about the frequency of monitoring. Control of monitoring and measuring. When equipment or process environment is found not to conform to the requirements, then we must assess the validity of the previous measuring results. I want to talk about this for a second. This is new, and this is great, and it wasn't written previously. What it means here is that if we have a measuring device, like a thermometer or like a dosimeter or a flow meter or a measuring device, any measure, a pH meter, it must be calibrated. Like all measuring devices according to ISO 9001. However, if that